Friends, today we are going to do theorems on triangles, and two triangles on the same base and between the same parallels are equal in areas. So today we will prove two triangles that stands on the same base and are between the same parallels. They are equal in area. So let's go towards the theorem. Now, as the question says, two triangles on the same base, which stand on the same base and between the same parallels are equal in area. So we need two triangles to start this theorem, that both of the triangles are standing on the same base and it should be between the same parallels. Okay, let's take two triangles between the same parallels. Suppose two line is a suppose this is this line and this line is a parallel. This is a parallel line. These two lines are parallel and we need to make two triangles stand on the same base. Suppose this is one triangle. This is one triangle, you can name it A, B, C. Now on the same base you have to draw another triangle. You can name it D. Now what do you see here? This line is parallel to this line and the base is same. There are two triangles A, B, C and triangle D, B, C, and their base is BC. Base is same and also they are in between the same parallels. So we have to prove that if this is the case, that means if it is on the same base and between the same parallels, we have to prove that their areas are equal. So given, how do you start? Given triangles, there are two triangles ABC and DBC. DBC stands on the same base BC. BC is the base where these two triangles are standing and are between the same parallels. As you see, this line, you can name it AD or name it LM, any name you can give. AD, the line AD is parallel to BC. So in between these two parallels, these two triangles are standing. So what is given? Triangle ABC and DBC stands on the same base BC and are between the same parallels AD and BC. AD and BC. Now, what do you have to prove? To prove what the theorem says, if they stand on the same base and between the same parallels, then what their areas are equal. That means you have to prove area of these two triangles. First triangle is area of triangle ABC is equal to area of triangle DBC. We have to prove this. So before proving this, we need to do some constructions. We need to make some constructions. So write constructions. What do you have to do in the constructions? Now, this line is already parallel to this line BC. Now from here you need to make constructions. See, from this point C, what you have to do? Draw a line parallel to BD. Okay? From C you have to draw a line parallel to BD which meets this parallel in a certain point. Okay, let's draw it. Okay, and name it E. Now, from point C, what you have done just now? From point C, you have drawn a line CE parallel to BD, which meets the line on at point E. So, what you have to write now? From C, what you have done? From C, CE parallel to BD. Drawn. Now see this point. From the point C, you have drawn CE parallel to BD. C parallel to BD is drawn, and the parallel line that C just you have produced met this parallel line at the point E. Okay. Similarly, you need another construction also from this point B. From this point B, you have to draw a line parallel to CA. So you have to draw a line parallel to CA. And which meets at this point, and you can name it as F. So from this point B, you have drawn a line BF parallel to CA. So again from point, which point? From point B, what you have drawn? BF parallel to CA. BF parallel to CA is drawn. Okay, this is your construction. Now your construction is complete. So this is your construction. Now what you have to do? Proof. Now you have to start proving. Okay, let's. Everything is clear up to here. Now we will start proving. Proof. Now how do you prove it? Now see this figure, see this quadrilateral FBCA. In quadrilateral FBCA. In quadrilateral FBCA. FBCA. Now, if you can prove this quadrilateral FBCA is a parallelogram, similarly, if you can prove this quadrilateral DBCE is a parallelogram, then it will be easy for you to prove this theorem. It will help you to prove the theorem. Now, in quadrilateral FBCA, what are the properties of parallelogram? Now it is quadrilateral. We have not yet proved that this is a parallelogram. So the property of parallelogram is if the opposite pair of sides are equal and parallel, they are called parallelogram. Now let's check it. Now here, in quadrilateral FBCA, we can write FB is parallel to AC. FB is parallel to AC. How FB is parallel to AC? By construction, because this BF we have produced, which is parallel to AC. AC, CA, whatever you can write CA. Now the reason is, FB is parallel to AC, or you can write BF is parallel to CA. BF is, similarly, it doesn't make any difference. BF or FB, similar, same thing. So BF is parallel to CA. This is by constructions. Check the initial steps by constructions. Now BF is parallel to CA. This is by constructions. Another one. So we found out this one pair of opposite sides are parallel. So now if you find another pair of opposite sides parallel, then you can say that this whole quadrilateral is a parallelogram. Now check the sides FA and BC. Now as we have told that this line is parallel to BC. That means this part is parallel to this part. This line BC is parallel to this whole line. So this FA is a part of this parallel line. So if this whole line is parallel to BC, then part of this whole parallel line, part of this line, that is FA, is definitely parallel to BC. So you can write FA is parallel to BC. FA is parallel to BC. That is given. FA is parallel to BC, that is given, because FA is a part of this whole line, and this whole line is parallel to BC. So part of that whole line, that is FA, is parallel to BC. So what we have found now, the opposite sides are parallel. The opposite sides are parallel, meaning if the opposite sides are parallel, then we can say that this quadrilateral is a, now this quadrilateral FBCA will be a parallelogram. Since both pairs of opposite sides are parallel. Since both pair of opposite sides are parallel, therefore what you can write, this quadrilateral FBC is FBCA is a therefore FBCA, this one, FBCA is a parallelogram. So as I told you, the property of parallelogram, if you can find out that both pair of opposite sides are parallel, then you can say that quadrilateral is a parallelogram. Now if you look close to this figure FBCA, now it is already proved that it is a parallelogram. Now if you check it very closely, what you can see here, AB is a diagonal, right? Now you can see that AB is a diagonal here. Now what is the property of a diagonal? The diagonal of a parallelogram divides the parallelogram into two congruent triangles. Now this AB is a diagonal of the parallelogram FBCA. So what is the property? Always you have to remember that diagonal of a parallelogram divides the parallelogram into two congruent triangles. And what are the properties of congruent triangles? We have done it earlier. Congruent triangles, the property of congruent, if the two triangles are congruent, then their areas are also equal. Remember, if two triangles are congruent, then their areas are equal. So what you can write, AB is the parallel, AB, since AB is the diagonal, since AB is the diagonal of the parallelogram of the, I will write insert parallelogram to save the time, but in your exam, in your test, you have to write the full spelling, Parallelogram, parallelogram. Insert parallelogram. Now AB is the diagonal of parallelogram FBCA. FBCA. Now the property of parallelogram, the diagonal bisect the parallelogram into two congruent triangles. So what you can write here, therefore, now AB is dividing. This AB is dividing these two triangles. So what is the name of this triangle? Triangle FBA. And what is the name of this triangle? Triangle ABC. So they are congruent. So what you can write here now? These two triangles are congruent. Triangle ABC is congruent to triangle FB. ABC is congruent to triangle FBA. FBA. So the reason is already there. I have already written the reason why they are congruent, because this figure FBC is a parallelogram and this AB is a diagonal, and the diagonal of a parallelogram always divides parallelogram into two congruent triangles. Now since these two triangles are congruent, and we also know the property of congruent triangles, that if any two triangles are congruent, then their areas are equal. So now you see these two triangles are equal, so what you can write, their areas are equal. Therefore area of triangle ABC is equal to area of triangle FBA. What is the reason? The reason is this one, because these two triangles are congruent, therefore their areas are equal. What is the reason? Since triangle ABC is congruent to triangle FBA. This is the reason. Now we have proved that area of triangle ABC is area of triangle FBA. Now in this figure FBCA, in this figure, when you add these two triangles, the figure is FBCA, right? When you add these two congruent triangles, you will get a parallelogram. This triangle plus this triangle, when you add it, it gives a full figure, that is a parallelogram FBCA. So therefore, what you can write, therefore this triangle, triangle FBA plus this triangle, what is the name of this triangle? ABC. Triangle ABC equals to, these two triangles equals to, now see, these two triangles are the part of this parallelogram. That means when you add these two triangles, you will get the figure parallelogram FBCA. So you will get parallelogram FBCA. Now, or just now you have proved this, right? You can prove this. Now, triangle FBA plus triangle ABC is equal to parallelogram FBCA. Now, in place of triangle FBA, you can replace this. Triangle FBA can be replaced by C, because just one step before we have proved area of triangle ABC and area of triangle FBA is equal. These two is equal. So in place of triangle FBA, you can replace this. Because you have already proved that these are equal, areas are equal. So in place of triangle FBA, you can replace it by writing triangle ABC, right? So in place of FBA, what you can write? Triangle ABC. So here is triangle FBA, you can write triangle ABC plus, in place of, we are replacing FBA by ABC. Why? We have already proved here in this step. So triangle ABC will remain same, is equal to parallelogram FBCA. Now triangle ABC and triangle ABC, when you add it up, it will become twice triangle ABC equals to parallelogram FBCA. Now simple now two triangle ABC is equal to parallelogram FBCA. So just say triangle ABC. Now when you simplify, triangle ABC equals to, now these two will go on the right hand side in the denominator. So what you can write, half into parallelogram FBCA. FBCA. So this is your equation 1. This is your equation 1. So what you have found here, triangle ABC is equal to half parallelogram FBCA. So this is 1. Now you have come to the conclusion, triangle ABC is equal to half of parallelogram ABCA, equation number 1. Now you can take another quadrilateral. Now you have taken this quadrilateral, you come to equation number 1. Now you can take this quadrilateral, another quadrilateral DBCE. Now in quadrilateral, you can take this quadrilateral DBCE. Now in this quadrilateral, again you need to prove this DBCE is a parallelogram, but it is easy to prove it, like before we have proved in this quadrilateral. So what you can write here now? Here CE is parallel to BD. CE is parallel to BD, and that is very obvious that CE is parallel to BD. This is by construction. By constructions we have done. Now, as I told you, this BC is parallel to this whole lines FE, and DE is a part of this whole line. So if this whole line is parallel to BC, then this part DE is also parallel to BC. DE is also parallel to BC. So it is given that because these two triangles are standing between the same parallels. Now you come to know that this both sides of this quadrilateral are parallel. So therefore what we can write, therefore this quadrilateral DBC is a reason, what is the reason? Since both pairs of opposite sides are parallel, since both pair of opposite sides, meaning CF is parallel to BD, D is parallel to BC, that means we can say DBCE is a, therefore DBCE is a parallelogram. Now it is proved that DBC is a parallelogram. Now again use the property of a diagonal. Now in this parallelogram DBC, what is diagonal here? DC is a diagonal. So as you know the property of a diagonal parallelogram, this diagonal DC divides this whole parallelogram into two congruent triangles. What are those triangles? One is DBC, another one is DCE. So since what is the diagonal? DC. DC is the diagonal of parallelogram. DC is the diagonal of parallelogram DBCE. DBCE. What you can write? Since DC is the diagonal of parallelogram DBCE, therefore now this diagonal DC will divide this parallelogram into two congruent triangles. So what you can write now? Therefore triangle DBC is congruent to triangle DCE. DCE. The reason diagonal is dividing these two parallelogram into two congruent triangles. Now if these two triangles are congruent, then therefore their areas are equal. Therefore area of triangle DBC is equal to area of triangle DCE. Now their areas are equal. As you know the property, the reason is since triangle DBC is congruent to triangle DCE. So this is the reason. Triangle DBC, area of triangle DBC is equal to area of triangle DCE. The reason is because they are congruent. Now again this DBCE is a parallelogram which is compiled of two triangles, this triangle and this triangle. Meaning when you add this part, this triangle DBC and this triangle DCE, you will get this whole figure, parallelogram. So right, therefore when you add these two triangle DBC plus triangle DCE is equal to, when you add up these two triangles, what do you get? The whole parallelogram. Parallelogram DBCE. Now triangle, now see here, DBC will remain as it is because we need this triangle DBC. Now in place of triangle DCE, now just one step before, area of triangle DCE is equal to triangle DBC. Meaning in place of DCE you can write DBC. So here is DCE. So according to this step, replace this DCE by DBC. So because these are equal, both are equal. So in place of DC you can write triangle DBC is equal to parallelogram DBCE, and or when you add this triangle DBC plus triangle DBC twice triangle DBCE ABC is equal to parallelogram DBCE. Now simple simplification. Now you can do simple simplification, and when you simplify, when you send 2 on the right hand side, you will go as a denominator. So you can write it as, therefore triangle now DBC. Triangle DBC is equal to half into parallelogram DBCE. DBCE. This is equation number 2. Now this is equation number 2. So from equation 1 and 2, there are 2 parallelograms, right? We are dealing with 2 parallelograms, parallelogram FBCA, parallelogram DBCE. Now go back to these 2 parallelograms. Now when you go back to these 2 parallelograms on the diagram, check it properly. Parallelogram FBCA. FBCA is also a parallelogram whose base is BC, right? The base of parallelogram FBCA is base is BC. And another parallelogram DBCE. DBCE is also a parallelogram and its base is also BC. That means what you come to the conclusion, these 2 parallelograms stands on the same base BC. And another one, not only that, not only these 2 parallelograms stands on the same base, also they are between the same parallels, because this line FE is parallel to BC. So 2 things, these 2 parallelograms FBCA, the base is BC and between the same parallels. Again another parallelogram DBCE stand on the same base BC, and again they are between the same parallels. And in previous theorems we have learned that in theorems of parallelograms, what you have learned, if 2 parallelograms stands on the same base and are between the same parallels, then the area of these those parallelograms are equal. So as you have seen that these 2 parallelograms stands on the same base and between the same parallels, what you can write? Their areas are equal. They are equal. So you can write, therefore, now this area, what you can write? Parallelogram FBCA. Parallelogram FBCA is equal to parallelogram DBCE. DBCE. Now why they are equal? You need to write the reason, right? Why they are equal? As I said, any 2 parallelogram, if they stand on the same base and are between the same parallels, then their areas are equal. Area parallelogram FBCA is equal to area parallelogram DBCE. Now the reason why they are equal, the reason, you can write the reason here. What is the reason? Both parallelograms stands on the same base BC. Is both parallelograms are standing on the same base BC and are between the same parallels, FE and BC. FE and BC. So this is enough. These 2 reasons is enough to prove that their areas are equal. And this property of a parallelogram, we have done in previous classes while doing the theorems on parallelograms. Once again I repeat, when 2 parallelograms stands on the same base and are between the same parallels, then their areas are equal. Now from 1 and 2, now as I told you, these are equal from 1 and 2. From 1 and 2. Now, since these are equal, meaning since these are equal, so in equation number 1, ABC will have parallel FBCA, and in equation 2, triangle DBC will have parallelogram DBCE. So from 1 and 2, you can write like this, simple. You can write, therefore, you can repeat equation 1. Triangle ABC is equal to half into what is there? Parallelogram FBCA. Right? Now, or triangle ABC. Triangle ABC is equal to half. Now, as we know, parallelogram into parallelogram, that these two parallelograms are equal. So, in place of FBCA, we can write DBC. Both are same. Their areas are equal. So, this FBCA, the parallelogram FBCA, we can replace it by DBCE. You can write it, right? Why? Because their areas are equal. These two parallelograms are equal. We have already proved it. So in place of FBCA, we can replace it by DBCE. So therefore, triangle ABC equals to now triangle ABC is equal to half parallelogram DBCE. Check equation number 2. Equation number 2. In equation number 2, half into parallelogram DBCE. Half into parallelogram DBCE. This means half into parallelogram DBCE means triangle DBC. So remove this all the terms, because half parallelogram DBCE is triangle DBC. Actually triangle DBC. So you can replace this all half parallelogram DBC by triangle DBC from equation 2. From equation 2. So what is already, it's already proved now. Triangle ABC is equal to triangle ABC. Therefore, these two triangles are equal. Therefore, area of triangle ABC is equal to area of triangle DBC. This is what we want. What we are going to prove. Proved QAD. So now it is proved that area of triangle ABC is equal to area of triangle DBC. And what are the now in the theorem we need to prove that these two triangles, if they stand on the same base and are between the same parallels, then their areas are equal. So finally we have proved that their areas are equal. Area of triangle ABC is equal to area of triangle DBC. Thank you very much.